Okay, so we're going to look at the second lesson in which we're using radians and solving trig equations. And again, we did these last year with degrees, but the only difference is we've got to use radians. And we've got 6 cos squared theta plus sine theta minus 5 equals 0. And if you remember last year, we couldn't solve equations in which we had cos squareds and sines in the same equation. And we had to use that trig identity that we knew, which was sine squared theta plus cos squared theta equals 1, which meant I could replace my cos squared theta with 1 minus sine squared theta. Okay, so substituting that into here for cos squared theta, I'd have 6 times 1 minus sine squared theta plus sine theta minus 5 equals 0. Obviously got to expand the bracket. 6 minus 6 sine squared theta plus sine theta minus 5 equals 0. And I want to turn that into a quadratic. I want to make it equal to 0. Personally, I like to have positive quadratics. So I'm going to multiply through by minus 1. So I'd have my 6 sine squared theta minus sine theta, and I'd have minus 6 plus 5, which would be minus 1, equals 0. So I've got a quadratic. You know, I'm going to do my typical thing. I'm going to say sine theta equals x. So I've got 6x squared minus x minus 1 equals 0. If I were to factorise that, I'd have 3x and a 2x and a 1 and a 1, and it would have to be that way round. It'd have to be 3x plus 1 and 2x minus 1 equals 0. So I would have either x equals minus 1/3, because 3x would equal minus 1, and so x would equal minus 1/3, or I would have x is equal to a half. So coming back to my sine equation, that would mean either sine theta equals minus 1/3 or sine theta equals a half. Okay, and using my calculator, I do inverse sine of minus 1/3. So I'm going to split my page actually and put that one over there and this one over here. So I'd have theta equals, like I say, put it in my calculator, I get minus 0.34 radians. Okay, but the range I need is between 0 and 2 pi, and that is not between 0 and 2 pi. So I'm going to use my unit circle. I've got my radian of minus 0.3, so it's down here somewhere because I've got that as minus 0.34, or in this case it's just 0.34 below. Where else is the sine the same? Well, if we remember, the sine is the height of this triangle, so it's also the same over here where that's a size of 0.34. So going with my circles, I need to go pi plus 0.34, and I also need to go 2 pi minus 0.34. So I'll put them in my calculator and I should get 3.38 and 5.94 radians. Okay, so they're the two solutions between 0 and 2 pi. Right, now I need to do sine theta equals a half. Well, if I do inverse sine of a half, I end up with pi over 6, because it's one of these exact values that we have. Again, using my unit circle, I've got my pi over 6 here. Where else is it the same? It's the same up over here because it's the height that's the sine. So that's pi over 6. So again, I've got my theta equals pi over 6, which was the first solution, and the second solution is pi, take away pi over 6, because I go all the way around to pi and come back again. So my solutions are pi over 6 and 5 pi over 6. So what are the solutions to my original equation, which is 6 cos squared theta plus sine theta minus 5 equals 0? I just want to write them as one list: 3.38, 5.94, pi over 6, 5 pi over 6 radians. Okay, so there's the first one. Just do one more example like this, but this time I'm going to do a different range. I'm going to go between minus pi and plus pi. But again, I can't have an equation with cos and sine squareds in. So I need to use sine squared theta is 1 minus cos squared theta. So in this case, I've got 17 cos theta plus 3 lots of 1 minus cos squared theta equals 13. I'm going to expand that out. So I'm going to get 17 cos theta plus 3 minus 3 cos squared theta equals 13. It's a quadratic, need to make it equal to 0. I like to have positive cos squareds or x squared, so I'm going to take everything to the right hand side and I'm going to end up with 0 equals 3 cos squared theta minus 17 cos theta, and I'm going to take it plus 10. Okay, so again I'm going to say let cos theta equal x. So my quadratic becomes 3x squared minus 17x plus 10 equals 0. Bit of a more tricky one to solve. And to be honest, at these points, you can put these in your calculator and you get x equals 5 or x equals 2/3. Coming back to my equation in cos, that means either cos theta equals 5 or cos theta equals 2/3. Well, you can try it. You can try doing the inverse cos of 5, but we know cos only goes between 1 and minus 1. So actually, cos theta equals 5 has got no solutions. Okay, so you have to cross it out. You have to write no solutions. Can't just ignore it. You've got to write why you're ignoring it. So going back to my other one, so I've got cos theta equals 2/3. So theta is going to be 0.84 radians when you do the inverse cos of 2/3. And again, we go back to our unit circle. So we've got 0.84 rads or radians. Now this time it's the cos theta, so it's the base of this triangle. So where else is it the same? It's down here. Again, this angle is 0.84 in size. So because I'm going between plus theta and minus theta, my two answers are quite simple. 0.84 and minus 0.84 radians. Okay. And the last one looks a little bit different, this one, but actually it all comes down to the same thing. It's got a bit of a trickier range, this one. But easiest way to think about this is to think about what we know about tan. And we know tan x is sine x over cos x. So I can substitute that into there. So I can get cos x equals 3 sine x over cos x. Still a bit tricky, but multiply through by cos x to get rid of that denominator, and you end up with cos squared x equals 3 sine x. Now, like before, we can't have equations with sines and cos squareds, so we have to use our cos squared x is 1 minus sine squared x. So on the right hand side, all the little bits that we're using. And so I end up with 1 minus sine squared x equals 3 sine x. Now I've got an equation just in sine, so, but it's a quadratic. Make it equal to 0, and I get sine squared x plus 3 sine x minus 1. Okay, so I'm going to say let y equal sine x. So I've got y squared plus 3y minus 1 equals 0. Now, that isn't going to factorise, so we need to put it in. So we've got a y of 1, a coefficient of y squared as 1. We've got the coefficient of y as 3 and minus 1. And we end up with y is equal to 0.3028. I would personally keep at least 3 decimal places, possibly 4. Or y is equal to minus 3.3028. Okay, so going back to our sign, so that means either sine x equals 0.3028 or sine x equals minus 3.3028. Well, again, we know sine only goes between minus 1 and 1. So that has got no solutions, but we have to write it. So if our sine x equals 0.3028, what is our x? Well, we do the inverse sine of 0.3028 and we end up with 0.3076. Now, what did it want it to? It wanted it to 3 significant figures. So I may as well write this one to 3 significant figures, which is 0.308 radians. Now, we've got to use our unit circle again because it wanted the solutions between 0 and 3 pi, which is 1.5 complete rotations. So we know our sine x is up here. We know that that's 0.308 radians. Sine is the height of this little triangle that we can create. So the other one is over here where that's 0.308. So our solutions are, well, we've got the first one, 0.308 radians. We've got the second one, which goes to pi and comes back. So I've got pi minus 0.308 radians. And then we've got the third solution, which does a complete circle and goes to pi, which is 2 pi plus 0.308. But we've got a fourth solution because remember, we're going all the way from 0 to 3 pi. So I'll just get rid of a few of these, sorry. And so if we think about 3 pi, that would involve a complete circle and another one. So we've got this final solution up here, and that's going to be 3 pi minus 0.308. So we've actually got 4 solutions to this. 0.308 radians. Now I haven't worked these out before, so I have to do shift pi minus 0.308, which is 2.83 radians. Remember, keeping it to 3 significant figures, plus 0.308. It's got 2 pi plus 0.308 is 6.59 radians, and the last one, 3 pi minus 0.308 is 9.12 radians. So they're the 4 solutions to cos x equals 3 tan x between 0 and 3 pi. Okay, right, there we go. 4 for you to have a go at. As usual, press pause when you've finished, press play, and I will show you the solutions. Okay, so here come the solutions. Number 1, managed to fit it all on one page for you. So again, we've got to use sin squared equals 1 minus cos squared. We end up with the quadratic equation, which is 3x squared minus 7x minus 6 equals 0. I did factorise, but you can use your calculator. If you want to practice your factorisation, though, it's always a really good way to do it. So we end up with cos theta equals 3 or cos theta equals 2/3. Well, the first one's got no solutions. Second one, we've already done this one, 0.841 radians. And we're going between 0 and 2 pi this time, though. So if we think about going between 0 and 2 pi, this second solution down here is 2 pi take away 0.841. So we end up with 0.841 radians and 5.44 radians. Right, next one then. So again, between 0 and 2 pi. This time cos squared equals 1 minus sine squared, which leads us to the equation 6x squared minus x minus 2 equals 0. Two solutions. We've got sine theta equals minus a half, or sine theta equals 4/3. Well, 4/3 is bigger than 1, so again that has no solutions. So if we look at sine theta equals minus a half, we get minus pi by 6, so that's down below the x-axis on the unit circle down here. So the other solution is on the other side, because remember we're thinking about the height of the triangle. This time we want to go between 0 and 2 pi. So we need to go pi plus plus pi over 6. And we have to go 2 pi, take away pi over 6. You end up with 7 pi over 6 and 11 pi over 6. Right, number 3. This time we're going between minus pi and plus pi. And again, we end up with one answer that gives us no solutions. Cos theta equals minus 3, but cos theta equals a third gives us theta is 1.23 radians. And because it was cos, it's quite nice and easy. So you just get plus and minus 1.23 radians. And the last one. So we've got 3 cos squared theta minus 5 sine theta minus 1 equals 0 between minus pi and pi. Okay, so end up with a quadratic 3x squared plus 5x minus 2 equals 0. So we get sine theta equals minus 1, or sine theta equals 2/3. Both of these are going to have solutions now. So inverse sine of minus 1 gives you minus pi over 2. So that's in this first unit circle here. So it's directly down on the unit circle. So if we're going between minus pi and pi, that's the actual solution, minus pi over 2, because there are no solutions in the 0 to pi region, and there's only one solution in the 0 to minus pi region. Then if we look at the second answer to our quadratic, sine theta equals 2/3. Inverse sine it, we get 0.73. And so our solution is 0.73 and pi minus 0.73. So our three answers are 0.73, 2.41 and minus pi over 2 radians. And don't worry about some of it being decimals and some of it being exact. The question hasn't specified to 2 significant figures or 3 significant figures or anything like that. So you can have this mix and match answers. If you wanted to write them all to 2 or 3 significant figures, that's fine as well. But the examiner wouldn't mind if you have this little bit of a mix, because it hasn't specified what form it wants the answer in the question. Okay, and that's it for today. So again, have a look at the questions that we want you to do and send them in. Thank you.